So for my project, I made a flower predictor, and the prompt is that Bobby is a scientist and he's in a competition with other researchers to find out information about many different flowers, and he has to keep a journal a secret where he makes all his notes so that another team does not copy him. And we need to help Bobby build an app where he can ensure that his data is being protected from malicious hackers who want to use SQL injection or hack into the database. Way that Bobby's going to do it. So Bobby is going to be given the length of a flower and the width of a flower, and he wants to be able to say what kind of flower is it. Is it a blue flower or is it a red flower? So here's a machine learning project that I built using the NumPy library. Basically, we have many data points. So this the in this multidimensional array, the first point of the array is the length of the flower, the second is the width, and 1 or 0 is the second or third indice of the array, each array, and it denotes that the flower is either red or blue. So if it is close to 0, that means it's a blue flower, and if it's close to 1, that means it's a red flower. And so our machine learning code right here, what it's going to do is going to, based on the parameters of the length and the width, the machine learning, this neural network is going to be able to tell us, is it a blue flower or a red flower? So we gave many data points for us to make these predictions, but then we have this mystery flower right here with a length of 4.5 centimeters and a width of 1 meter, 1 centimeter. Okay, and so Bobby wants to figure out what is this? What is this? Is this a blue flower or a red flower? And so one of the things we need in order for this neural network to function is an activation function, which is a sigmoid function. And this sigmoid function, it basically simplifies our algorithm. And what it does, it's an exponential function which it takes an input x, and the output will be any value between 0 and 1. So it's basically making it so that the output is always going to be 0 or 1, which is what we want, because we need to be able to only have 0 and 1 as an output. We don't want anything else as an output based on our inputs. So, and right here we have the derivative of the sigmoid function, and the reason we're going to take the derivative is because we want to find the slope and multiply it with the when we find the cost function, which will come later when we find all the partial derivatives. So in this training loop, we have our weights and biases, which is what allow the algorithm to make the prediction. So we have we just assign it random values. So we have weight 1 and we have weight 2 and we have a bias. And all of them are just initially given random values from the NumPy library. Um, and we're going to do 10,000 iterations in this loop with the learning rate of 0.1. And the reason I chose a learning rate of 0.1 is because 0.1, it will be able to allow for the percent error to be like not too high. So it'll become a lower percent error within like 0.1. And then we'll have a cost function, and the cost function is useful because what the cost function will do is it will take the correct value. So we know what the correct values of, if the correct value meaning, is the flower red or is the flower blue? The flower is, so we're going to take the correct value and we're going to subtract it from whatever the neural network predicted, and based on that we're going to see, and we're going to keep on trying to make it better and better, the prediction better and better. And so this is our for loop that we're going to do an iteration, 10,000 iterations, in which we're just going to get a random data point. Then we're going to apply the weights and biases. And the way the neural network works is that in the beginning, the weights and biases are totally random, which is why the prediction is going to be really bad. But as we apply the cost function, which is taking the minimum of the function, we're gonna see how do we minimize the error, and we minimize the error as much as possible in order to we minimize the error as much as possible so that we can have our prediction as accurate as possible. So after 10,000 iterations. So this is going to be iterated for 10,000 times in this for loop, but I'm just going to go over one iteration. And so the basic idea is that what we're doing, we're taking a random data point and we're going to apply the random weights and biases, and then we put in the sigmoid function, so it's between 0 and 1. And then what we're going to do is we create this cost function, which is taking the predicted value right over here, and subtracting it from the target value. So the neural network predicted something, which is totally random, and we're going to subtract it from the target. And then we're going to take the square root, so it's always positive. I mean, we're going to square it, so it's always positive, because we don't want to deal with the negative value. And so in the beginning, obviously the difference between the prediction and the target is going to be very big, but the goal is that we want to take the minimum of this function, the minimum percent error that we can get. And so in order to find the minimum of this cost function, if we were to graph it, it will not be a 2D, since there are three variables. It's not going to be a two-dimensional function, it's a three-dimensional function. And to find the minimum of a three-dimensional function, we have to use the partial derivatives in order to calculate the slope, and we have to decrease the slope every single time. So this right here is all just applying the chain rule. We're just applying the chain rule in order to basically decrease the cost. We want to find the minimum of the function. In order to find the minimum of the function, we have to take the partial derivatives, and then we just multiply it times the learning rate, and then adjust the weights and biases this way. And so after doing this 10,000 times, the weights and biases will get better and better until they're almost perfect. And then we can predict it, and then at this point we have a perfect weight and a perfect bias. We have two perfect weights and two perfect biases, which will allow us to, any data point that we give the neural network, it will be able to produce a prediction that is very accurate. And this is after only training the neural network over 10,000 times, training it 10,000 times to get the perfect weights and the perfect biases. And then after that, we just apply the sigmoid function. So it's a value between 0 and 1. And we get this right here. And we see for this mystery flower, with a length of 4.5 and a width of 1, the neural network predicted that it is 0.99, which is very close to 1, because any value that's close to 1 is a red flower. So our friend Bobby, he can make an accurate prediction that this is going to be a red flower. And so now that he has this really valuable information, he worked really hard to build this neural network to predict this, or at least we helped him build this neural network. What we have to do is, how do we make sure that no other malicious hacker can steal his hard work? So we built a web application for him, which is incorporated with SQLite. And so Bobby's secret data. So basically Bobby, he's going to be given the flower, and he's going to enter the dimensions in this web application. So for example, he will put in 4.5, which is the length of the flower, and he'll have the width of the flower, which is 1. And now, based on the neural network prediction, he's going to be able to say, well, after running the neural network, we see that it says that it's 1. So where he's going to enter the flower color as red. Okay, so he's just going to enter as red. And it's encrypted so that, we will make sure that no malicious hacker can get it. So yes, we just going to enter into the data. We're going to enter it. So where does this information go? This information actually went to our SQLite database, and we're going to look at it right here. So this is the code for the web application, where we have our database right here. It was written, the front end was written in PHP, and the back end was with HTML and CSS. And right here we have the SQLite code in order to, and so what we're going to do is, now that he entered the information, the secret information, right over here, he entered the information. So what we're going to do is we're going to see where is this information being stored and how is it going to be protected by malicious hackers. So here's, let me just so here's a SQL database. So we want to open the data. Okay, so here, so it automatically creates a .db file, and so we can open it. At any time Bobby enters a piece of data into the website, automatically .db file is created. And so in the database, we see that we have the lengths of the flower, we have the width and the height of the flower, and we have a hash. We have the most important piece of data that Bobby has is whether or not the flower is red or blue. And we see we don't want anyone else to know, so we have a hashed code right here, which protects Bobby's data, which is the red color or blue color. For example, if Bobby was to enter another one, let's say he entered 9 and 10, and he said this is a blue flower. So he knows it's blue. And now in the database, this entry should appear again. So if we just go here and open the file again, we see that the new data, the new entry, the new piece of data that we just entered, it's in the SQL database, and it's with the hashing code. So if someone wants to hack it, no, they can't figure out what it is. It's not just written plainly. It's a completely random sequence of characters, which is hashed. And we can see how this is applied in the in the SQL code. We see that right here we use the function password hash, which hashes the function. It's a form of data protection, so that if anyone wants to figure out what is Bobby's the color of the flower, they can't, because the password is hashed and only Bobby can know, and it will be saved for him. So this is basically the essence of the app, and this is how Bobby will hopefully not get his information stolen.